All right, ladies and gentlemen, welcome back. So to continue on in our algebra review, we're going to take a look today at graphing and solving systems of linear inequalities. Okay, so it's going to change things up just a little bit. We already talked about graphing linear inequalities, where we either do a dot, dashed, or straight line, solid line rather, and then we shade in one direction. Well, we're going to do the same thing, but with multiple equations. Okay. So the first part here says the following shows two inequalities graphed in the same set coordinate system. With your table, make some observations about the graph and describe what stands out to you. So what do the shaded areas represent? Well, if you take a look at this, okay, the darkest shaded region is where both of the graphs overlap. So darkest shaded region is where both graphs overlap. Okay, and then like the lighter shaded regions, lighter shaded regions is where only one graph solutions work. Well, if you take a look, then it says what about the regions that are not shaded? What about this part over here? So this part over here is where nothing works, okay? No solutions for either equation or inequality. Okay, cool. So real quick, darkest shaded region is where both graphs overlap. The lighter shaded region is where only one graph solutions work, okay? And then about the regions that are not shaded in, nothing works, no solutions for either inequality. Okay, so we're gonna take a look at some systems of linear inequalities. A system of two linear inequalities and two variables. That really is the exact same definition. That's hilarious. Solution of a system of inequalities, an ordered pair that is a solution of each inequality in the system. So here's the thing. Before we talk about where the graphs meet, okay, where they crisscross, it's one solution. You're going to see that there is an infinite amount of solutions for inequalities because there's an infinite amount of points. And then the graph of all solutions of systems. Let's see here. Steps for graphing. Graph the line of each inequality. Don't forget to determine if the line is dashed or solid. Shade the proper half plane for each inequality. And then we're going to graph the system in the region that's shaded for both patterns, okay? So we're gonna take a look at our first example here. Graph it. It's already in y equals mx plus b form, so we get kind of lucky here. Here's the thing with these. Take your time, all right? Sometimes it's really good to use a pencil, and I'm gonna show you guys about shading in one direction. Y is greater than or equal to x minus 1. My y-intercept is -1. I come down here, I plot a point. My slope in this one, even though it just says x, is going to be 1 over 1, so up 1 over 1. And I'm just plotting a few points. Okay. It is greater than or equal to, so it will be a solid line. Make sure I got my arrows on there. Now, since it is greater than or equal to, okay, we want to shade above. So watch how we're going to shade this. Pick one direction. Normally I say kind of follow the line, all right? And just draw little lines, straight lines going this way. Okay, so now notice how I'm doing them lightly. You'll see why in a minute, kind of like the first graph we did with the lighter gray and then the darker gray. All right, if I just graphed above it, by the way, also because it was greater than or equal to, if you need to do a test point, you make like you test 0, 0. 0 is greater than or equal to -1, it works. Okay. My second graph, -2x plus 1. So my y-intercept is at plus 1. I'm going down 2 over 1, down 2 over 1, down 2 over 1. Okay. Since this is less than, I'm going to do a dashed line. Okay. Now, this is less than, so less than I'm going to shade below it. So I'm going to shade below that line. This can get confusing, but pick your direction again, and we're going to shade across. Now, you're going to notice that I have this up here is just shaded one direction. This down here is shaded one direction. This in the middle is where it crisscrosses. So this is going to be my solution set. Now go back and shade it in. Please try to be careful. Notice how this is a dashed line right here. When you shade it, try not to get rid of that dash. You want to still represent that dashed line. Wonderful. Okay. It's as simple as it can be. Very nice. On the back, right? So let's take a look at graphing the system in quad one. So in quadrant one, we know where that's at up here. But here's the thing, whether you're in physics class or wherever you may be, you're going to see this a lot where they give the parameters of x is greater than or equal to 0. Well, x is greater than or equal to 0 is a solid line. It's a vertical line that goes straight down through the origin. Y is greater than or equal to 0. That's a solid line that goes through the origin, horizontal line. And they want to be greater than or equal to 0 this way, greater than or equal to y this way. You can shade this, but why don't we just wait? Okay. The reason I'm saying wait is because the more you shade, the more confusing it gets. I know I'm in quadrant one. It tells me I'm in quadrant one. So we've graphed our first two lines. We know we're right here. Just hold off on it. As far as this goes, let's get y by itself. Okay, I know you guys can use Desmos, but you do need to know this. You need to get y by itself. So practice makes perfect. Subtract 3x over, divide everything through by 2. Y is less than negative 3/2 x plus 4. Okay, 4 is my y-intercept. All right, down 3 over 2, 1, 2, 3 over 2. Down 3 over 2, 1, 2, 3. You don't have to do more than 1 point, more than 2 points. I'm just showing them because just give you guys all the lines there. You do want to take your time, make sure you can draw a straight line through it. This is going to be a dashed line. So dot, dot, dot. Okay. I'm less than that, so I would normally shade down this way. Now, guys, I know we can shade everything all the way across, but since I know I'm in quadrant one, I know I'm below that dashed line. Take your time, and we're just going to shade right in here. Make your graph look pretty. Cool. Wonderful. Okay. And again, this is something that you'll typically see in a word problem, so on and so forth. All right. Our last example problem here, then, it's a little bit more like a word problem. Okay. So you are selling a $6 adult tickets and $4 youth tickets for a school play. Sorry, guys, I can't pause the video. I apologize for the phone ringing. You want to sell at least $600 worth of tickets. Okay. So write and graph a system of linear inequalities that describes the information above. What's the least amount? I know it's annoying. I'm so sorry. I'm just so popular. People want to call me all the time. It's crazy. Okay. The least amount of adult tickets you can have is 0. So 0 is less than or equal to x. Like you can have like x is greater than or equal to 0. So it's probably better if we read it that way. Sorry, I got flustered by the phone call. There we go. Same thing, just wrote it in reverse. What's the least amount of youth tickets you can have? Well, okay, 0. So we start off by saying that. Now I'm going to call adult tickets x and youth tickets y. All right. If I know it costs $6 for an adult ticket, so I can write 6x plus I know it costs $4 for a youth ticket for y. And I want to sell at least $600 worth of tickets. So greater than or equal to 0. Okay. Now, wonderful. There's my system. Okay. There's my system right there. I've got my 3 graphs. All right. So if I want to graph this now, all right, I know that x is greater than or equal to 0, y is greater than or equal to 0. What does that tell me? What quadrant do I have to be in? Well, I have to be over here, right? Okay. Oh, I just realized it needs to be greater than or equal to 600. Sorry, I put 0 there. The phone call just threw me all off my rhythm. Good deal. If I can get y by itself, okay, boom, boom. I can divide everything through by 4. Okay, that'll go 1 or 50. Okay, that can reduce down to 3/2. Okay, so there's my graph. Now, if I'm going to graph this, again, I'm only in quadrant 1, so I probably drew this graph a little poorly. I should have probably made it a little bit bigger in quadrant 1. My y-intercept is 150. Okay, so I need to go up 150. I'm going to go up by 25s. 25, 50, 75, 100, 150, 125, 150. Okay. Now, one way to look at it, all right, I'm going to see if this makes sense, but I'm going to go down 3/2. Well, since I went up by increments of 25, all right, I'm going to go ahead and say I'm going to go down 30. I'm going to go over 20. 10, 20. All right. So down 30 would be 25 right about there. All right. So I know my y-intercept's 150. Now I'm making a best guess there. Something that might help you out, all right, is to know what the x-intercept is. All right. So if I want to find the x-intercept, I'm showing you guys a little bit of side work here. X-intercept. The x-intercept is when y equals 0. So if I plug a 0 in for y up here, okay, and since I'm trying to find the intercept, we can change this inequality into an equation. Subtract the 150 over. All right, if I multiply by the reciprocal, -2/3. That's going to cancel out here. I know that x is going to equal -150 divided by -3 is 50 times 2 is 100. All right, so my x-intercept is going to be 100, 0. So if I come back down to my graph, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right. Boom. Okay. Since I'm only in quadrant 1, I want to be greater than or equal to. So that means above this line. So I'm shading above it. All right. And again, my scale is a little bit off because I did increments of 10 down here and I did increments of 25 right there. All right. So, I mean, by all means, change your graph to make it suitable for you. You sell 80 adult tickets and 100 youth tickets. Did you reach your sales goal? Well, you can do this one of two ways. One, if you look at your graph over here, 80 is about there, and then 100 is about there. So, I mean, graphically, I can see that that point is up top. Is it in the shaded region? Yes. Okay. So, I mean, graphically, I did. Just to show you guys, though, that's my x, that's my y. I'm going to plug it into, does it meet these two requirements? Is 80 and 100 greater than or equal to 0? Yes. Okay, so now I'm going to plug it over here. 6 times 80 plus 4 times 100. See if that's greater than or equal to 600. This gives me 480 plus 400. Okay. 880 is greater than or equal to 600. That's a true statement. So did I reach my sales goal? Yes, I reached my goal. All right, good stuff. Okay, so good job, everybody. Keep the good work. And as always, good luck. We're all counting on you.